Hey folks, welcome back to the Everything in Swift. And sorry for being missing for a while, I was quite busy with the interviews. Let's solve the today Leetcode problem. It's the sort colors. So given an array of numbers with n objects colored in red, white, and blue, so that implies the words implies algorithm mean like we have to solve the colors without using the extra variable, like just using the single array, and they have to sort in that array so that the object can be the same color adjacent with the color in order red, white, and blue. So one thing to know is that the input of the color will be only 3 for maximum, like 0, 1, 2, which represent the red, white, and blue. So we have to solve the problem without using the native library sort function. Normally, if we use a native sort library, like sort function, is will be the O of n log n, which is in here. So according to the question, we are not allowed to use a native sort algorithm, and then we were trying to solve the algorithm by in-place by ourselves. So one need to know is that if we have a problem like sorting, so we have to check the input, like input can be varies or what is the arbitrary count for the input. But in our case, the input of the values are limited, like 0, 1, 2. So what we can do is we can use something like partitioning sort. What I mean by partitioning sort mean like we trying to, let's say we have an array in here, because we know that our input can be maximum of 3, like 0, 1, 2 for sure. Or we can put like all the 0 go to the left side, all the 2 go to the right side, all the 1 to the middle. So it was automatically sort without using any other sort algorithm. Okay, let's try to understand the problem a little bit. So in here, I was trying to use the 3-pointer algorithms to do the partitioning sort. Let's try the demo a little bit. So what can I do is like, I will trying to use a 3-pointer like right, left, and the index. So let's say the index can be moved from like left to right or something else. So we may need to have something like while loop, then check the index is lower than the right, because we are pretty sure our index of the index will be lower than the right index. So in that case, we can keep track of our while loop to always loop and loop through the iterator for the whole array. So what do we do? If the index is 0, we can swap the left and index. But if the index of the value is 2, we have to swap between the index and right. So if we use like this, we're gonna swap the index and right. So it will become 2 up here and then 0 will be here. For the index, we need to move the right index to the left for 1. So in that case, we can lower down the array side to solve the problem in like this. So next step, we also need to detect the index by -1. But for that case, I will explain the code for the delay. So our index is now in the 0, and then if we go for the next iterative proof, so index is same with the left, so we just swap the index. Left also shift to the right for 1. Index also shift 1, the same. So if it is also the same, the left will move to the here, index also move here. Now we have to check index is 2 again. So what do? We swap the index with the right, so which will create like this. So 2, this will be the 1, because since we swap the right and index, then our right will be moved here by a little bit, then there. After that, index will also skip in the same place, and then we have to check is 1. What do? We move the index by here, and then if index is same, then index will move there, and then all the loop will there, and then the array will be end up in the sort case. Okay, let's try to run through for this one. So I think this one will be much more descriptive than the previous one because it's only the input is only 3. What do? The index is now the 2. So we have to swap the right and the index. So this will be 2. If we swap it, this will be 1. And then after swap, we increase the right to here. And then left will remain the same. And the index also remain the same. So next approach is 1. So we move the index to here. And if it is 0, we swap the left and index. So left is 1, index is 0. So we have to swap like this. Become 1, this become 0. After that, index will pass to the right index, and then we are now done for the sorting. Alright, let's deep dive into the code. So we're gonna need the 3 variable. Left will be the 0 index, and the right will be the num.count -1 since this is a right index, or the index will be 0. After that, what we need in here is we have to check the quotation if index is less than or equal to the right. So that's our case. If num of the index is 0, what can we do? Do swap for left and index. After that, +1 to the left. Now to check for another case also, index is equal to 2. That means we have to shift between the index and right. After that, we decrease the 1 from the right, and then same for the index also. But when we keep track of the index, then we will increment the index back after the while loop. So after that, we have two options. We can use the swap function from the Swift, or we can do the create the swap function by ourselves, since we don't want to create the extra space in here also. Let's create the swap. Let's just call it like first and then second. So what we can do, so we keep the temporary value first, and then we will put the first with the second, and then the second with the temp. So we can do the swap in here. Left and index, same for here, index and right. Let's try to run through it. Alright, let's submit the problem and see how it goes. Right, I think it's solved 100% for the runtime, and then 85% for the memory. I think for the memory it will be the O of 1, since we don't use any extra data structure in here, and then for the runtime it will be the O of n. Alright, that's all for today. Thank you and see you in the next video.